There are two general classifications of shapes in geometry, and the first is concave. And these are examples of concave shapes. And you'll notice that all of them have indentations in them, and the indentation creates angles on the inside of the shape that are greater than 180 degrees. Also, with concave shapes, it's possible to connect 2 points on the perimeter with a segment that leaves the shape, that lies outside the shape. Now, by contrast, convex shapes are like these four. And in convex shapes, all the angles are less than 180 degrees. And also, if we try to draw a segment that connects 2 points on the perimeter, that segment will lie entirely within the shape, as these examples show. Now, this year, we are going to be focusing solely on convex shapes, these sorts of shapes, and not concave. So we'll work with these. And the next slide gives you some examples. Along the left-hand side here, we have pictures of different regular polygons. And they are regular because in any one shape, all the angles, for example, in this pentagon, are congruent, and all the sides are also congruent. And that's what the word regular means in reference to polygons. So we have a triangle, a square, a pentagon. A 6-sided shape is called a hexagon, a 7-sided shape a heptagon, and an 8-sided shape an octagon. And I'm going to record the number of sides that each has. So we have 3, 4, 5, 6, 7, and 8. In the next column, I want to record the sum of all the interior angles. And as you well know, for a triangle, the sum of all the interior angles is 180 degrees. And then for a square or any 4-sided shape, the sum of all the angles is 360 degrees. But you might not know offhand the sum of all the angles in a pentagon. And the way to figure it out is to break the pentagon into triangles. So from any one vertex, you can draw diagonals. And when we draw diagonals from that one vertex, we see that we have 3 triangles. And the angles in those 3 triangles add up to all the angles in the polygon. So it looks like since we have 3 triangles, and each has 180 degrees, the total here for the pentagon must be 540 degrees. Let's do the same thing for a hexagon. Again, if we draw the diagonals from any one corner, we break the shape into triangles, and in this case we have 4 triangles, each with 180 degrees, so the grand total for a hexagon is 720 degrees. At this point you might notice a pattern emerging, and for a 7-sided shape we'll end up multiplying 180 times 5, and the total number of degrees in a heptagon is 900. And then finally for an octagon, we'll use 6 times 180 degrees, and that gives us 1080 altogether. In the final column, let's see if we can get the measure of each interior angle. And because all the angles in this triangle are the same, and there are 3 of them, then we can simply take our 180 degrees and divide by 3 and get 60 degrees. And in our next picture we have 4 angles, and they add up to 360 altogether. So 360 divided by 4 gives us 90 degrees. For a pentagon, we'll take 540 degrees and divide by 5, and that gives us 108. And for a 6-sided shape, we'll take 720 and divide by 6, and get 120 degrees. For a 7-sided shape, we're going to take the total of 900 degrees and divide by 7, and that result is 128.57 degrees, a little bit of a messy answer. And then finally for an 8-sided shape, 1080 divided by 8 is 135 degrees. Let's finish this slide now by generalizing what's going on in these columns. First of all, instead of working with a specific number of sides, let's call the number of sides n. So we're going to work now with an n-gon instead of any particular number of sides. And as you can see from our earlier work, we are always multiplying 180 by 2 less than the number of sides. So our formula for the second column is n minus 2 times 180. And that should feel right, because no matter how many sides you have in a polygon, the number of triangles you can draw is always 2 less than the number of sides. And then finally, if the shape is regular, then we can take that grand total of n minus 2 times 180 and divide by the number of angles, which is n, and we have the measure of each interior angle. One final thing I want you to notice in these columns: first, in the middle column, we're always adding 180 degrees every time as we take our journey down. So this is a linear function. We're always adding by the same amount. By contrast, the final column over here, all these values are increasing, but they are increasing by smaller and smaller quantities. First we add 30, then we add only 18, then we add only 12. So these numbers, while they continue to grow, they're growing by smaller and smaller amounts each time. And it's actually approaching a limiting value of 180 degrees, but we will never get a full 180 degrees in any interior angle of a polygon. Let's now turn our attention to the exterior angles in polygons. And we have a picture here of a regular pentagon, so it has 5 sides, and the interior angles are marked in red. Those are the ones that we've talked about. And for a pentagon, the sum of the interior angles is 540. Now let's pay attention to the exterior angles. If you extend the sides of a polygon in a systematic fashion all the way around the shape, you create exterior angles, and they're marked in blue. And because this is a pentagon, there are 5 of them in this case. And in any shape, no matter how many sides the shape has, the exterior angles always add up to 360. And here's why. Imagine taking a journey around this shape. If you start at this corner and you start walking, when you take a turn here, you're turning through an exterior angle. And then you continue over here, again over here, and again over here, and then you finish up back here. And when you walk around a shape, you basically turn 360 degrees, so the sum of the exterior angles always equals 360 degrees. And that's going to be very helpful, because when we work with shapes with many sides, we often won't know right away what the sum of the interior angles equals, but we will always know that the exterior angles add up to 360 degrees. Let's now use what we've learned to solve a few problems. And I would suggest that you try to stay ahead of me here, or pause the video and see if you can anticipate what I'm going to be doing. In this first problem, we're trying to get the measure of angle x. We know that the other 3 angles, and we know that all 4 of them together must add up to 360 degrees. So the equation that we'll write is x plus these 3 angles, which I've calculated to be 277 degrees, has to equal 360. And then you could solve that equation and get x. In the second picture, we have 1, 2, 3, 4, 5 different angles. So this is a pentagon, and we know that the sum of the angles in a pentagon must be 540 degrees. So that 540 must equal all 5 of these angles. And I have 2 expressions involving x, so that's 14x. And then there are 3 angles, and the sum of those 3 angles is 302 degrees, so we'll have plus 302 here. And again, you could solve this equation for x, and you'll have your value for x. In this next diagram, we have 1, 2, 3, 4, 5, 6, 7, 8 angles. So this is an octagon, and we know from our earlier work that an octagon is made up of 6 triangles, because it's an 8-sided figure, and 6 times 180 is 1080. So I know the total number of degrees is 1080, and now I'm going to collect my x's, and there are two of them here, two expressions involving x. So there are 32x degrees plus, and then if I add up the remaining angles that have numerical values, all of those, I get 824. And then I could solve that equation and figure out what x equals. In these last two examples, we're going to focus on the exterior angles. And what's great about exterior angles is that we know that they always add up to 360 degrees. So in this first picture, I know that 360 has to equal 4x plus 3x, which is 7x, plus the four other angles, which together, those four values total 248. So again, we could solve this equation and know what the value of x is. In the final picture, we have 1, 2, 3, 4, 5, 6, 7 angles, but we know that their sum is always 360 degrees because they are exterior angles. And we have in this collection an x, an 8x, and a 4x, which together make 13x. And then we also have the angles, 42, 50, 45, and 54, which total 191 degrees. On this slide, I haven't solved any of the equations for x, but I trust that you were able to do that on your own. In this next collection of problems, I want to focus on just this diagram and then the two problems down here. In this diagram, we have to do a little work before we can set up our equation. And the first thing to notice is that inside the triangle, this angle will be 100 degrees, and this angle will be 138 degrees. And I figured that out because we have sets of linear pairs there. These two have to add up to 180 because they're a linear pair, and these two have to add up to 180 because they're a linear pair. And now we can set up our equation. This is a pentagon that we're working with, so we know that the total of all the angles has to equal 540 degrees. And then we have in here 3x plus these three angles, which add up to, I think, 348. And again, you could solve that equation from here. These next two problems require us to work backward. And in the first one, we're told that the sum of all the interior angles of the polygon are 1,620 degrees. Now, we know the expression for the sum of all the interior angles is n minus 2 times 180. So that must equal 1,620. And I think to solve this equation, I would divide both sides by 180. And when I divide 1620 by 180, I get 9, which means that n must equal 11. In the next problem, we're told that the measure of each interior angle of a regular polygon is 179, and we're asked how many sides it has. I think in this particular case, it's easier to turn our attention to the exterior angles, and a diagram might help. So I'm going to draw one vertex of the polygon, and although it's not drawn to scale, I know that the interior angle is 179 degrees. So if I now draw the exterior angle, so I'll extend one side off to in this direction, then this angle must be only 1 degree. And again, it's not drawn to scale. Now, I know that the sum of all of these angles has to be 360. All of these exterior angles has to be 360. So that means that this shape must have 360 sides. Let's now finish by looking at these last four problems. In the first one, we're asked how many sides a regular polygon has if each exterior angle is 15 degrees. Well, we know that all the exterior angles have to be 360 degrees, so we can just take 360 degrees, divide it by 15, and that answer is 24, so that is the number of sides. In the next problem, We're asked how many sides, again, a regular polygon has, but here we're given that each interior angle has a measure of 108. Now, I think it's easier to work with the exterior angle. So we know that the exterior angle in this shape must be 72 degrees, because the interior and exterior must always add up to 180. So now we know the exterior angle, so we can take 360 and divide by 72 degrees, and we get 5. So 5 is the number of sides, so this is a pentagon. In the next problem, we're again asked for the number of sides, but this time we're told that the sum of the measures of the interior angles is twice the sum of the measures of the exterior angles. So we'll see if we can set up an algebra equation. The sum of the interior angles we know is n minus 2 times 180, and we know that the sum of the exterior angles is 360. So twice the sum of the exterior angles must be 720. And if we solve this equation, I think I would first divide by 180 and get n minus 2 equals, and then 720 divided by 180 is 4. So that means that n must be 6. So we must be talking about a hexagon in this problem. And now let's look at the last problem. We're told that the measure of each interior angle of a regular polygon is 8 times that of an exterior angle, and we're looking for the number of sides. And I think here a picture would help. I'm going to draw one corner of a polygon, so it might look something like this, and the polygon continues around, and this is the interior angle right here. And then I'm going to extend the side, and then this will be the exterior angle. So I'm going to call the exterior angle x, and that makes the interior angle 8x, because it's 8 times as big. And I know that their sum has to equal 180 because they're a linear pair. So I'm going to set up that equation. X plus 8x equals 180. And that means that 9x equals 180, so x equals 20. And that is the measure then of this exterior angle. But that's not the answer they're looking for. What they want to know is how many sides does the polygon have? Well, if one exterior is 20 degrees, I can figure out how many sides there are by taking 360 degrees, which is the sum of all the exterior angles, and dividing by 20 degrees, and I get n is 18. So this must be an 18-sided shape. And that's it.